All right, we're still in Chapter 2, and this is Lecture 5 of Macroeconomic Data, and we're going to talk about fixed weighted versus chain weighted index numbers. So the first thing we're going to do is we're going to talk about a fixed weighted index number that a lot of us have heard about. Probably you remember this from principles of macroeconomics. It's called CPI, or the Consumer Price Index. And the Consumer Price Index is what we call a fixed weighted index number. In other words, like we saw on the GDP deflator, we saw those weights that were on the prices in the previous lecture. We said they could change over time. Well, in CPI, those weights don't change over time. They're fixed. So to see that, let's just keep going. We'll talk a little bit more about the Consumer Price Index. One major component of a price index is, well, what goods prices do we include in the index? And so the CPI includes a measure of price levels of a typical consumer's basket of goods. So on average, what does a consumer buy? It's published by the Bureau of Labor Statistics, and it has a lot of uses. So we use it to track changes in a typical household spending or cost of living. Many labor contracts use these as adjustments for inflation, or what are called COLAs, cost of living adjustments. A major one of these policies that have these COLAs in there are, for example, benefits for Medicare and Social Security. Those are tied to the Consumer Price Index. And allows for comparison of dollar amounts over time. So anytime we want to compare, say, what was the cost of a gallon of gas in 1950 versus what was the cost of a gallon of gas today, we want to use some kind of a price index to account for the change in overall price level, so that if we see, how much has a gallon of gas actually changed in real terms. So, how does the BLS construct CPI? Well, first of all, it takes a survey to determine composition of the typical consumer's basket. It does this in the base year. So this basket of goods, right, or collection of goods of the typical consumer, that's determined once. Okay, and after that's determined, they continue to calculate the index. And then every month they collect data on prices of all the items in the basket and compute the cost of that basket. And so they'll do that by everything from doing telephone surveys to actually looking at the data to going to stores and finding the data on how much does such and such cost. And they have to be careful about certain things, like, for example, a hamburger might cost a certain price in one store, but another price in another store. And so they have to deal with all those changes. And they deal with that all in the data collection process. Okay, so the basic formula for calculating CPI is the cost of the basket in the current month. All right, the cost of the basket in the current month, and the cost of the basket in the base period. But notice, the basket stays the same. All right? So what we're doing is we're saying, okay, I want to know how much does it cost me to buy this group of goods now versus how much did it cost me to buy that group of goods then. So if we take a look at this, we can kind of split out the CPI to see overall how different parts of the economy contribute to it. And we see there's several different categories, everything from food to housing to apparel to transportation, recreation, education, communications, other goods and services. We see this seems very, very logical for things we might buy on a given day. And you'll notice that the biggest one by far is housing. All right? And almost 42% goes into housing. Well, that's an important thing to note when we're looking at CPI. Could, say, a massive decrease in housing cost, well, could that mask inflation in other prices? Well, sure it could, right? So sometimes we have to be careful of that. Every once in a while, we will calculate something called core CPI, and essentially what we do from that is we eliminate food and energy. And the whole reason for doing that is because food and energy are kind of volatile. You might say that's kind of a dopey reason for getting rid of something. Well, yeah, it probably is. But we'll talk more about the core inflation rates when we talk about monetary policy, because that's where they're really relevant. So let's take a step back and let's understand the CPI in a way similar that we understood the GDP deflator. So if we take a look at CPI, what does CPI equal? We have CPI, and that equals, well, and we're multiplied by 100, but I'm just going to ignore the multiply by 100 for right now. That equals the expense of our basket in right now, time period t, divided by our expense of our basket in the base year. And then, of course, it's times 100. So let's split this out a little bit more, just like what we did before with GDP deflator. That equals what? Well, what's the cost of that basket today? Well, it's the price. Say we have 3 goods in our basket. Price of good 1 in time period t times the quantity of good 1 in the base year, right? Because we keep the basket held fixed, plus the price of good 2 in time period t times the quantity of good 2 in the base year. Again, we keep the basket fixed, plus the price of good 3 in time period t, so the current time period, that's what I mean by time period t, times the quantity of good 3 in the base year, because it stays fixed. Right? Divide that all by the expense of the basket in the base year. So if I break that out and rewrite this fraction in the sneaky way I did before, I end up with what? I end up with the quantity of good 1 in the base year divided by the expense in the base year, all right, times price of 1 times t plus, all right, I'm probably going to run out of room because I'm writing too big, but it'll be okay. Quantity of good 2 in the base year divided by the expense in the base year plus, times price of good 2 in the current period plus the quantity of good 3 in the base year divided by the expense of the whole basket in the base year times price 3 in time period t. Okay, now notice there's something very subtly different here about this index number than about the one that we saw with GDP deflator. Notice these weights do not change over time. All right? This is important. The weights do not change over time. That's why we call this a fixed weighted index number. The weights are fixed. Okay, so keep that in mind. That's really important. The GDP deflator, we call that a chain weighted index number. And one of the nice things about that is the weights can change over time. But the CPI is a fixed weighted index number, and the weights can't change over time. They are fixed. Why? Because it's always comparing the cost of the same basket of goods. We don't let that basket of goods change at all. So, because CPI is a fixed weighted index number, it is been shown to overestimate the inflation rate. In other words, it says that price level grows faster than it actually does. And there's some reasons for that. The first reason we talk about is substitution bias. In other words, when the price of, say, bananas go up, well, maybe I just buy more oranges and fewer bananas, and I'm equally happy. But CPI makes me buy the exact same amount of bananas and the exact same amount of apples, even if I might decide to substitute more apples to get a lower cost combination of fruit that I like just as well, right? So the problem with CPI is it doesn't let me substitute cheaper goods when this relative price changes. Okay, that's an important thing. It doesn't allow those weightings to change. All right, and there's also the introduction of new goods. So if I have a chain-weighted index number like GDP deflator, there's no problem when an iPad comes along or a newer calculator or whatever, newer, cooler good comes along. I can easily add that into the index number. With CPI, in order to add new goods, I have to change the base year. And there's a problem with changing the base year in a fixed-weighted index number. In a fixed-weighted index number, when you change the base year, you change everything. In a chain-weighted index number, you don't change as much, and we'll see that in just a minute. All right, and unmeasured changes in quality. So for example, say we have a personal computer from 1990 versus a personal computer from 2013. Okay, so basically, a reasonably low-end laptop from 2013 would have passed off as a reasonably low-end supercomputer in 1990. I mean, let's face it. I mean, it's just computing power has exploded over time. There's a much bigger increase in quantity or in quality of that good. So that isn't reflected within a fixed-weighted index number. And it's to a limited extent reflected into a chain-weighted index number. That one's hard to deal with. Okay, so let's compare two index numbers. So in your textbook, it compares chain-weighted real GDP deflator to the fixed-weighted CPI. All right, so you can see that that graphic in your textbook. What I've done for here is a little closer comparison. So the problem with comparing GDP deflator to CPI is that there's two different baskets of goods. So what I've got here is a chain-weighted CPI, which that index number actually begins around 1999, I believe, is when they first started calculating that, and a fixed-weighted CPI. So the chain-weighted CPI uses the exact same goods, but uses a better index number to calculate them. The fixed-weighted GPI is the standard CPI, and now we can kind of see the difference. And you can see how the fixed-weighted GPI, and what we have here is this is the inflation rate. So I have the percentage change in the index number over time. You can see that the fixed-weighted index number has a tendency to overstate inflation. Not by a whole lot, but it does have a tendency to do so. If we take a look at the averages, chain-weighted CPI over this time period averaged about 2.2% inflation rate, whereas the fixed-weighted CPI averaged about 2.45%. So just slightly more. Okay, so in this lesson, we've looked at the difference between a fixed-weighted and a chain-weighted index number. I haven't said very much yet about how you calculate a chain-weighted index number and why in the world is it called chain-weighted in the first place. Well, in the very next lecture, we're going to go through that very, very thoroughly. Okay, so see you next time.